All right, here are our solutions for quiz 7 from Math 111. We're given a polynomial and asked a bunch of stuff about it. So the first thing it wants us to do is state the end behavior of the polynomial. To figure that out, you can just look at the term with highest degree, in this case x cubed. Since this is an odd number, that means it goes in different directions when it goes to the right and when it goes to the left. So if it goes up here, it goes down here. If it goes up here, it goes down here. And then look at the leading coefficient. Since there's a positive one here, what that means is it goes up when it goes to the right. So to recap, because this is a positive number, it goes up in this direction. Because this is odd, it goes in a different direction when it goes to the left. So since it went up this way, it goes down this way. In other words, as x goes towards infinity, when I go to the right, y goes to infinity. When it goes to the right, it goes up. As x goes towards negative infinity, in other words, when I go to the left, y goes to negative infinity, it goes down. Right, up, left, down. It's the end behavior. And that's the picture that kind of describes this notation. Find the y-intercept of this polynomial. Y-intercepts happen when x equals 0. So all I gotta do is change all the x's into zeros. 0 cubed is 0, minus 5 times 0 squared is 0, plus 3 times 0 is 0, plus 9 gives me 9. The y-intercept is at 9. Or if you want to write it as a point, it's at the point 0, 9. I don't care which of these two you give me, either one's fine. Using the rational root test, list all possible x-intercepts of the polynomial. So the possibilities for x-intercepts are integer factors of the constant term, which in this case is 9, divided by integer factors of the leading coefficient, which in this case is 1. So the factors of 9 are plus or minus 1, plus or minus 3, and plus or minus 9. These are the only integer factors of 9. The integer factors of 1 are just 1. So what that means is I can either do positive 1 or negative 1 divided by positive 1 or negative 1. What that gives me is either 1 or negative 1. 3 over 1 or 9 over 1. I get that there's only 6 possibilities for x-intercepts of this polynomial that are rational numbers. That's what the rational root test tells me. Test x equals 1 and x equals negative 1 to see which one of these two values is a root of this polynomial. All right, the way you test them is you evaluate f of 1. To test 1, you evaluate f of 1. What I'm saying is put 1 into this polynomial and see what comes out. If 0 comes out, that means the point 1, 0 is on your graph. And if the point 1, 0 is on your graph, it means the graph goes through the point 1, 0. It means it got an x-intercept at 1. So what I'm saying is take the original polynomial, x cubed minus 5x squared plus 3x plus 9, change all the x's into 1s. I get 1 cubed. Is it plus 5x squared? Minus 5x squared. Minus 5 times 1 squared. Plus 3 times 1 plus 9. Make sure I copied that right. Yeah. And then I figure out what this is equal to. 1 minus 5 plus 3 plus 9. That's not 0. What is it? 12, 13 minus 5 is 8. It's 8, which is not 0. So x equals 1 is not an intercept, an x-intercept. However, if we figure out f of negative 1, it would be negative 1 cubed minus 5 times negative 1 squared plus 3 times negative 1 plus 9, which is negative 1 minus 5 minus 3 plus 9. Negative 1 minus 5 is negative 6, minus 3 more is negative 9, plus 9 gives me 0. So x equals negative 1 is an x-intercept. Intercept. So up here in part C, I figured out we have these 6 possibilities. I just checked 2 of them. I didn't check the 3's and the 9's. I checked plus or minus 1. Found out 1 doesn't work, but negative 1 does work. Okay. Moving on, use polynomial long division to start factoring this polynomial, then factor it completely. So if x equals -1 is a root, an x-intercept, then, I don't know, then x plus 1, x minus -1 is a factor. So what I'm saying is when I do polynomial long division, and I do x plus 1 divided by my polynomial, which was x cubed minus 5x squared plus 3x plus 9, I believe. When I do this polynomial long division, I should get no remainder. It should divide evenly into there because x plus 1 is a factor of this polynomial. Let's see. To get rid of this x cubed, I need to put an x squared up here because x squared, let me change colors, otherwise this stuff all runs together. That's better. So what I was saying is to get rid of this x cubed, we work from the left to the right, I need to put an x squared up here. Because I take this x squared and I multiply it by x plus 1 and get x cubed plus x squared. And now when I subtract, note my x cubes go away. So that's why I had to put an x squared up here. So I subtract, these go away, negative 5x squared minus 1x squared is negative 6x squared. It'd be really easy to call this negative 4x squared, that's where people make mistakes on these, but you're subtracting. You always subtract when you draw these lines. Negative 5 minus 1 is negative 6. Then you repeat. You want to get rid of this negative 6x squared. To do so, I have to put something up here so that when I multiply that something by x plus 1, I get negative 6x squared down here. And that something is negative 6x because negative 6x times x is negative 6x squared. And now when I subtract, these go away. Positive 3 minus negative 6 is the same as 3 plus 6, which is 9x plus 9. Again, it's really easy to make this negative 3x, but it's not. It's 9x because we got to subtract. One more time, I want to get rid of this 9x now. I put a plus 9 up here. Reason why is 9 times x is 9x. 9 times 1 is 9. Now when I subtract, I get 0. That's a good thing. I was supposed to get a remainder of 0 because my polynomial f of x, which is x cubed minus 5x squared plus 3x plus 9 is really just x plus 1 times x squared minus 6x plus 9, plus 0 for this 0 remainder. So what I've done is I've started factoring this thing. I haven't factored it completely, but I started using polynomial long division. But now it wants me to finish factoring it. The way I can finish factoring it is I have to factor this. I need two numbers that multiply together to give me 9 and add together to give me negative 3. Negative 3 and negative 3 are those numbers. So what I'm saying is this polynomial completely factored looks like this. Now it says state all roots of this polynomial and their corresponding multiplicities. Now that we have the polynomial completely factored from part E, makes it easier to find all the roots. To find all the roots, I set this thing equal to 0. And so I have a product of three things equals 0. That means either x plus 1 equals 0, or one of these two x minus 3's equals 0. So that means either x equals negative 1 or x equals positive 3. Because this factor only appeared once, I say that the multiplicity over here is just 1. However, this x minus 3 factor appeared twice. So this root, this x-intercept at x equals 3, has a multiplicity of 2. So state all the roots. My roots are at x equals negative 1 and x equals 3. And their corresponding multiplicities. The multiplicity of this root is 1. The multiplicity of this root is 2. Sketch a graph of this polynomial. All right. Make sure to exhibit all of your answers from above. So what have I figured out so far? In behavior, it goes up to the right, down to the left. Okay. It's got a y-intercept at 9. Okay. So I want it to go up in this direction and down in this direction. I want it to go through the point 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want it to go through this point right here. And then I got x-intercepts at negative 1. So it should go through this point right here. And at positive 3. 1, 2, 3. I'm going to have to move this one over a little bit. And one more thing to be careful of, the root at 3, this guy right here, has even multiplicity. So it's going to bounce off this point. This x-intercept, the line's going to go right through. What I'm saying is it'll look something like, go through this point. But then when it gets down here, it's going to bounce off and turn around. A lot of things we don't know. We don't know how steep these lines are. We don't know how high up it goes over here, or if it turns around earlier. A lot of things we don't know. We do know it goes through these 3 points, and it passes through the x-axis at this point, whereas it bounces off it at this point. And that gives us the required end behavior. So there's an approximate graph of this polynomial. Call that good, and that's the end of the quiz.